Alright, so continuing solving trig functions by factoring. Here we got 3 tan x plus root 3 equals 0, problem number 9. So this is another one you don't actually have to do any factoring for. You can just use some algebra. So if you subtract the root 3 to the other side, you get 3 tan x equals negative root 3. And if you divide both sides by 3, you get tan x equals negative root 3 over 3. So it'll be helpful if you know in the unit circle that tan x is root 3 over 3 at the pi over 6 angles, the short sides. For tan x to be negative, you'd have to be in quadrant 4 or quadrant 2. So these two pi over 6 angles are 5 pi over 6 and 11 pi over 6. And those are the two answers for this problem. Alright, so for number 10, we've got this problem. 3 tan x minus 2 equals 2 tan x minus 7. It looks a little messy, so it looks like a good place to distribute on the left first. I think that would give us 3 tan x minus 6 equals 2 tan x minus 7. If we were to subtract this 2 tan x to the left, you'll have just 1 tan x. And if you add this 6 to the right, we'll get a negative 1. So tan x is negative 1 in two spots. They have to be in quadrants 2 and 4, and tan x is specifically the value of 1 when it's an over 4 or a 45-degree angle. So I'm going to draw a 45-degree triangle in the fourth and in the second quadrants. These two angles are 3 pi over 4 and 7 pi over 4. And there are only two answers to the original equation between 0 and 2 pi. For problem number 11, we're given a problem that is already a product equaling to 0, so we can ZPP immediately. So we've got 2 cosine x plus 1 equals 0, and 2 sine x minus 1 equals 0. And both of these have pretty straightforward processes for solving them. We get 2 cosine x, 2 cosine x equals negative 1. And if you divide both sides by 2, you get cosine x equals negative a half. And then the other one, we'll have 2 sine x equals 1, and sine x equals positive a half. And so let's think about in the unit circle, what is cosine x positive a half? That would happen at a pi over 3 angle. But to get negative a half, we'll have to be in the second quadrant or the third quadrant. And these two angles are 2 pi over 3 and 4 pi over 3. For sine x to equal a half, that would mean we need to have kind of shorter triangles at the pi over 6 angles. And the other place where sine is positive would be over here in quadrant 2, which is right around 5 pi over 6. And those would be our four answers within 0 and 2 pi. Alright, we've got one more problem for this video, number 12. So we're given tan x times secant x plus 2 equals 0. This is another ZPP problem. We can just split it up right away into tan x equals 0 and secant x plus 2 equals 0. The second equation we can of course solve and make secant x equal to negative 2. And if we flip this and make it a cosine equation, it'll be equal to negative 1/2. Now we just need to know where on the unit circle these two values occur. For tangent x to equal 0, we looked at this earlier. They would have to be at an angle of 0 or an angle of pi, because those are the two spots where the y values are 0, and tan x is y over x. For cosine x to be negative a half, that means we're going to have a tall triangle, and it's going to be in the quadrant 2 and in the quadrant 3. Those don't look very much like triangles, but don't do the best job writing on one of these styluses. These two angles turn out to be 2 pi over 3 and 4 pi over 3. So we have four answers: pi, 0, 2 pi over 3, and 4 pi over 3. And that's it for this video.